So welcome to this latest video 162 Maths, and in this video we'll be going over the GCSE Maths past paper of June 2024 on the higher tier paper 3, which is a calculator paper. Now before we get started working through this paper, a little reminder that if I have made any mistakes in this paper, firstly I do apologise, but I'll make a little note in the description, so please do check that out. I'll also include in the description a question breakdown so you can see which topic refers to each question. So if you get stuck on a question, you can see what topic it refers to and maybe go back and revise that topic. And I'll also include a link to the 162 Maths contents page, which gives you easy access to all the lessons which go over the topics in greater detail, topic tests, audits and other exam paper walkthroughs. So let's get started on question 1. So question 1 says, here are the first 3 patterns in a sequence made up of small squares. We've got pattern 1, pattern 2 and pattern 3 drawn. And for question 1a, it's asking us to draw pattern 4. Now what you want to do is you want to see similarities between each of the patterns. So as you can see in the middle, we've got a square and it's increasing its length by 1. So that means that in pattern 4, we're going to have a square of length 4 in the middle. So for this, if I do this neatly, because obviously I need to try and encourage good presentation, in which if I just make sure I've got enough space, I want a 4x4 grid. And then 4 little squares, which should look like this. And yeah, so you just need to make sure that your boxes are going along the lines and that you have drawn, and shading is optional, but make sure that you have got the boxes drawn correctly and neatly with a ruler. Now moving on to question B, it says the expression for the number of small squares in pattern n is n squared plus 4. Work out the least value of n for which the number of small squares is greater than 500. So for this, what we need to do is we need to set up our inequality. So we've got n squared plus 4 is greater than 500. And then we need to solve this inequality for n. So I've got n squared, take the 4 over, which is going to be 496. So n is going to be greater than the square root of 496, which if I type into my calculator is going to give me an answer of 22.3606, blah blah blah. Now, so therefore n, because we want the least value of n, that means that n is going to equal 23, because 22 will be too short. So if you were ever too sure, if you just typed in 22 squared plus 4, 23 squared plus 4, and what you're looking for is a value that's greater than 50. And remember, it is this number that you are writing in your answer. Moving on to question 2, it says use Pythagoras' theorem to work out the value of x. So if we label the triangle and then use Pythagoras' theorem, which is a squared plus b squared equals c squared, then what we end up with is 24 squared plus 31 squared equals x squared. Simplifying this on the calculator, we get 1537 equals x squared. So therefore, x is going to equal the square root of 1537, which on the calculator gives me an answer of 39.204 ... Now the question does say give your answer as a decimal, so you can round it up to whatever you wish. I'm going to go for 1 decimal place, and if you have rounded, whatever you round it to, just make sure you're stating what you've rounded it up to. Moving on to question 3, it says Rick claims most of the flats of his 8th-floor building are energy efficient. He samples 45 flats from floors 1 to 5. Give a reason why a sample may not be useful in testing Rick's claim. So again, what you want to say is something along that. For 1 mark, there's going to be multiple answers that are going to be expected, be allowed, I should say. So, but I would say 2 of the most common answers are going to be that it's not representative of all flats. So what we mean is the fact that the top floor will be the penthouse, and that typically is usually bigger, a bit flasher, so therefore it may be not as energy efficient, or it may be extra energy efficient because then you might have the solar panels, etc. So you don't need to go into huge amounts of details, but basically because there are flats missing from all 8 floors, that there's going to be some bias towards the bottom. You may also take that into account. Say that as another reason is that you didn't take into account floor flats on floor 6 to 8, and there we go. Moving on to question 4, it says 3 lots of x minus 1 is approximately identically to 3x minus 3 is an identity. Tick one box, and the box that we need to tick for an identity is that it's true for all values of x. Moving on to question 5, it says the front elevation of a cuboid is shown on this centimetre grid. The volume of the cuboid is 42 cubic centimetres. Draw the side elevation of the centimetre grid. So for this, what we've got is we've got a 2 by 3. Now, in terms of volume, it's going to be 2 times 3 times something, which equals 42. So that's 6 times x equals 42, so x equals 7. So when I draw my cuboid, that this is 2, that is 3, and I've just worked out that that there is going to be 7, and it's this that I need to draw. So what I need to do here is a 2 by 7 rectangle. So if I do it neatly, and it's going to be slightly askew, and let's just neaten up this side here, and so that's basically what I want to draw, which is basically 2 by 7. Moving on to question 6, it says on Monday Lars swims 50 meters in 40 seconds at a constant speed. On Tuesday Lars swims 1.5 kilometers. Assume he swims at the same constant speed as on Monday. How many minutes does he swim for on Tuesday? So for this, what we need to do is we need to look at making sure that we've got the same sort of consistent units that we have. So first of all, let's look at the speed on Monday, and that's in meters per minute. And the reason for that is because I've got meters, and if I scroll to where the answers are, I want the units in minutes. So for this, I'm then going to have meters, which is what the distance is measured, and that's absolutely fine. But here I've got the units of time being in seconds, so what I need to do is convert that into minutes. So here that's going to be 40 over 60, and if I type that into my calculator, I get 75 meters per minute. Now, the question actually asks what is the time in which Lars swims on Tuesday, so it's 1.5 kilometers. So 1.5 kilometers equals 1500 meters, and if you're doing 75 meters per minute, all I then need to do is 1500 divided by 75, and that gives me an answer of 20 minutes. Then moving on to question 6b, it says, in fact, on Tuesday, Lars swims at a slower constant speed than on Monday. What does this mean about the number of minutes he swims for on Tuesday? Tick the correct box. Well, if he's swimming slower, it's going to take longer. So therefore, the box you want to tick is the third box, which is it is greater than the answer in part A. Moving on to question 7, it says draw the graph of y equals 1 minus a half x for all values of x from minus 2 to 4. So for this, what we need to do is we need to draw a table of values. So we've got x and we've got y, and I've got the zeros of minus 2, minus 1, 0, 1, 2, 3, 4. Now for this, because it's going to be a straight line graph, I only really need to use 2 of the points, but it is really important on the mark scheme where a lot of students lost marks were that the lines didn't go from minus 2 for 4 for the x coordinates. So for this, how I always recommend my students to plot graphs is basically when x equals 0, then that's just going to be y equals 1. So one coordinate is 0, 1. When y equals 0, then x is going to equal 2. So another coordinate is 2, 0. So if I plot those 2 points, so I've got 0, 1, which is here, and 2, 0, which is here. All I've then got to do is draw a straight line through those points. And let me just make sure that it does. Now, as I mentioned, you need to make sure, now whenever you're plotting graphs, just make sure you go from one end of the graph paper to the next. It's the safest bet you can do. But if you just plot part of it, you're going to lose marks. And again, if your line goes over the graph paper, it's not a problem. As long as you're not interrupting anyone else's desk in the exam, you're going to be absolutely fine. Moving on to question 8, it says 4 people are taking part in a TV talent show. Here are Amy's marks from the 6 judges. The pie chart represents the telephone vote, and it says Amy's total score is found by 4 times the mean of her marks plus her percentage of the phone vote. And the question is asking us to work out Amy's total score. So let's first of all work out the mean of those scores. So the mean marks, or to work out the mean, what we do is we add up the numbers. So 8 plus 9 plus 9 plus 6 plus 10. And I feel like I've missed a number out there, so that's plus 9 divided by 6 gives me a mean value of 8.5. So that's the mean value. Then if we want to work out the percentage of the phone vote, well, that's going to be Amy's was 162 over the total angle, which was 360. And because we want the percentage, we multiply that by 100, which gives me an answer of 45%. So if I go back to how it's calculated, so the total score is going to be 4 lots of the mean, which is 4 lots of 8.5, plus the percentage score, which is 45. So if I type that all into my calculator, I get a score for Amy of 79. Moving on to question 9, it says town A has a population of 84,000 and an area of 7 square miles. Town B has a population density of 4,695 people per square kilometre. And we've got the formula for population density. And the question is asking us which town has the greater population density. Use 1 square mile equals 2.6 square kilometres. Now again, for these questions, it really does my head. And if you've watched my previous walkthroughs, you'll know how irritated I get with these. They shouldn't have the options first. They should have you working out and then you tick which box, because what students tend to do is they tend to pick which one and then provide working that generally supports or contradicts what they ticked originally. So when you get these questions, do your working out first and then tick the correct box. So for this, what we're going to do is work out the population density for town A. So town A, the pop density is equal to the population, which is 84,000, divided by, and we want the area in square kilometres. So because that is what population B is going to be. So it's going to be 7, because it's 7 square miles, and we're then using this scale to work out what the area is in square kilometres. So it's going to be 7 times 2.6. So if I type that all into my calculator, I get an answer of 4,615.384 blah blah blah. So what they want to compare is this value to this value. This is town A, that's town B, and as you can see, town B has got a higher population density. Moving on to question 10, it says that on a biased dice, the probability that it lands on a 6 is 0.38. This dice is rolled 150 times. How many times would you expect the dice not to land on a 6? So the probability of not 6 is going to be equal to 1 minus 0.38, which is equal to 0.62. So to work out the relative frequency is going to be 0.62 multiplied by 150. And if I type that into my calculator, I get an answer of 93. Then moving on to question 11, it says write a number in each box to make the calculations correct. So for this, the question is asking for 10 divided by minus 2 multiplied by something equals 5. Well, 10 divided by minus 2 gives us minus 5. And what do we need to multiply minus 5 to get positive 5? Well, that's going to be minus 1. Then we've got a third times 6 equals 8 pi. Well, a third times 6 equals 2. And I need to go from 2 to 8 pi. So what do I need to multiply 2 to get 8 pi? That's going to be 4 pi. Moving on to question 12, it says cards are either gold or not gold. The probability of gold is 0.5. Harry chooses a card at random and replaces it. He then chooses a second card, and for question 12a, it's asking us to complete the tree diagram. If the probability of gold is 0.05, then the probability of not gold is therefore going to be 0.95. And then as the probabilities are staying the same, this is going to be 0.95, this is going to be 0.05, and this is going to be 0.95. Then for 12b, it says, what is the probability of at least one of Harem's cards being gold? Well, for it to be gold, we've got the outcomes of GG, G and not G, G and not G, and G and not G and not G. Now, for that to be at least one card that is gold, it's either going to be one of these three. So for this probability here, it's going to be 0.05 multiplied by 0.05. And this one is going to be 0.05 multiplied by 0.95. And this one here is going to be 0.95 multiplied by 0.05. And if I add each of those three probabilities together, I get an answer for B as being 0.0975. Alternately, what you could have done is 1 minus the probability of not gold and not gold, in which you would have ended up with the same answer. So any of those would be fine for the 3 marks, which is quite a lot of marks if you do it the second way. Moving on to question 13, it says here is a quadratic graph with the equation of y equals f of x. And the question is asking us to write down the roots of the equation of f of x equals 0. So the roots are two values. One of them is this one here, and the other is this one here. So your roots are basically where the curve crosses the x-axis. And if you look at the graph carefully, then the two values you need to quote are minus 2.2 and 1.5. Moving on to question 14, it says that we've got a quadrilateral, and it says b equals 45 and a to b is in the ratio of 7 to 3 and x to y is in the ratio of 4 to 1. Show that a to y is in the ratio of 5 to 2. So for this, what we need to do first is looking at b, we can find a by using the fact that we've got a to b is in the ratio of 7 to 3. We know that b is 45 degrees, so what we then know is 3 parts equals 45, so 1 part is going to equal 15, so therefore 7 parts is going to equal 7 times 15, which gives me an answer of 105 degrees. So then from this we can then work out what x and y are. So x plus y equals 360 minus 105 minus 45, in which we get x plus y equals 210 degrees. So then using this total and using this ratio, that we've then got 210 equals 5 parts. So therefore 1 part is going to equal 210 divided by 5, which gives me an answer of 30. No, let's just double check that. So 210 divided by 5 gives me an answer of 42 rather. So then here times 4 by 42 and 1 by 42, and we get 4 times 42, which is 168, and 42. So now that we know the values of a and y, so a equals 105 and y equals 42, we can then write the ratio, which is a to y, which is 105 rather, if I can read my own handwriting, 105 to 42, which simplifies to 5 to 2, which is what they wanted me to show. Moving on to question 15, it says that a straight line passes through minus 5, 9 and b and c, which is at 3, minus 7. And the question saying that a to b to c is in the ratio of 1 to 3. Work out the coordinates of b. So if we look at this now, with these particular questions, particularly with ratios in geometry, I would always recommend turning this into a triangle and then looking at the dimensions of that triangle. So comparing the x coordinates, we've got minus 5 to 3, so that's got a base of 8. And then comparing the y coordinates, we're going from 9 to minus 7, which gives us a height of 16. Now in this, we know that the ratio is in 1 to 3. So a to b, b to c is in the ratio of 1 to 3. So we want to split this up into 4 parts. So if I split the height into 4 parts, well, I'd say that that is pretty much halfway. Again, not to be too accurate on this, in which we get these 4 parts here. Now going up, each part is worth 4. And going across, we've got each part which is worth 2. And so from this, we can then work out b. So b is 1 part, which, to be fair, my labeling is a bit sketchy, in which that then should be 4. So 4 down from 9 is 5. So that's my y value. And then going across, I'm going 1 value in, which is 2. So that's 2. And going from minus 5 plus 2 is minus 3. So my x coordinate is minus 3. So b is at the coordinate of minus 3, 5. Moving on to question 15b, it says work out the equation of a line perpendicular to AC that passes through C. So for this, what we need to do first is work out the gradient of the line AB, or AC I should say. So how do we do that? Well, we use the dimensions of our triangle. So it's 16 over 8 and it's negative. So it's minus 16 over 8, which gives me a gradient of minus 2. So therefore, the gradient of this new line, as it's perpendicular, is going to be minus 1 over minus 2, which gives me a gradient of a half. Now we know that C has got a coordinate of 3, minus 7. So using these 2 bits of information, I'm going to use, well, you could use y equals mx plus c. I'm going to go for y minus y1 equals mx minus x1, in which I've got y minus minus 7 equals a half x minus 3. And then from this, all we've got to do is simplify. So we get y plus 7 equals a half x minus, and that's going to be 1.5. And then we take the 7 over by taking away 7, in which we get final answer of y equals a half x minus 8.5. Or you can write it as y equals 0.5x minus 8.5. And that would also be fine for the full box. Moving on to question 16, it says Ying rolls a fair 6-sided dice 72 times. Is the relative frequency of rolling a 5 greater than the theoretical probability? And again, I say this again, I really get annoyed with the fact that they have these option boxes before you show your working out. So always do the ticking of the boxes last. work out the answer first and then tick the appropriate box. So for this, in terms of the relative frequency, it's using experimental probability of getting a greater than a 5 is going to be, oh no, it's greater probability of getting a 5, which is going to be 14 over 72, which if I typed into my calculator to get 0.194 recurring, then the theoretical probability, which is going to be a 6, which is equal to 0.16 recurring. So what I then want to do is compare this value to this value. So is the relative frequency greater than the theoretical probability? And the answer is yes, it is. Moving on to question 9, 17a, it says a and b are different prime numbers. A cubed times b squared is equal to 200. Work out the value of a to the power 4 times b. Now there's a couple of ways in which we can do this. We know that a and b are prime numbers, so this is a prime factor decomposition, or writing primes products as a product of their primes, in which if I get the calculator, now if your calculator's got a fact button, which most of the latest Casio calculators do, so if I type in 200, press equals, then the fact button, which gives us this, and we get 2, so 200 is equal to 2 cubed times, I think it was a 5, if I'm not mistaken, yep, 5 squared. So therefore a equals 2 and b equals 5. So then working out what a to the power 4 times b is going to be, well, that's going to be 2 to the power of 4 multiplied by 5, and if I type that into my calculator, I get an answer of 80. Now moving on to question 17b, it says c and d are different prime numbers. Circle the equation for which c to the power 4 times d squared times e is a cube number. So if it's a cube number, so if cube number, then each power must be a multiple of 3. So here we've got c to the power 4. So to turn that into a cube number, I need c to the power of 6. And to turn d squared into a cube number, I need another d. And, well, that's going to be d cubed. And e, well, that's what it's equal to. So for this, I'm going to need c squared. And for d to get d cubed, I need another c. So what I'm looking for is, I'm looking for c squared and d, which is my second option. Moving on to question 18, it says here is triangle A, and it says for part A, use the sine rule to show that x is equal to 64 degrees. So the sine rule is a over sine A equals b over sine b. So if I label this, we get this is a, this is little a, this is going to be b, and that's going to be, oh, and that's going to be little b. So what we've got is we've got 7 over sine 35 equals 11 over sine x. So then if I do a bit of cross multiplying, I get 11 sine 35 equals 7 sine x. If I flip it, I could just work on the right hand side. I get 11 sine 35 divided by 7 equals sine x. So therefore x is going to equal the inverse sine of 11 sine 35 over 7. And if I type that all into my calculator, I get an answer of 64.33, and then it's just a decimal number, which rounded gives me 64 degrees, and that's to 0 decimal places, which is what they wanted me to show to the nearest degree. Moving on to question 18b, it says here is triangle B. Anna thinks that W must be 64 degrees to the nearest degree. She says that this is because triangle B has two sides and one angle that is the same as triangle A. Without further calculation, is she correct? And the box that we need to tick for this is no. Now the reason for that is because the orientation of the triangle is completely different. So it's either you need to state that 35 degrees is a different angle, or you could say something along the lines of that 7 centimeters is on a different side. So something along the lines of mentioning the orientation of the angles and the lengths are different to triangle A would be sufficient for that one single mark. Moving on to question 19, it says f of x is equal to x minus 3 and g of x is equal to 4x minus 7. And the question is asking us to work out the value of fg of 6. So first things first, what we need to do is work out g of 6. And again, there's a couple of ways in which you can do this, but I'm going to do it this way. So g of 6 is going to be 4 lots of 6 minus 7, which is 24 minus 7, which gives me an answer of 17. And then if I then work out what f of 17 is going to be, well, that's going to be 17 take away 3, which leaves me with an answer of 14. It then says solve f of x all squared equals g of x. Well, we've told that f of x equals x minus 3. So this is going to equal x minus 3 all squared. And we know that g of x is equal to 4x minus 7. So recognizing that this is a double bracket question in which we get x squared minus 6x plus 9 is equal to 4x minus 7. Then from this, I'm hoping that you can see that this is going to be a quadratic equation. So if I take all of this over to this side, I end up with x squared minus 10x plus 16 equals 0, and then we just need to then go on and solve this. So it does factorize, so you can use a quadratic formula, so it's entirely up to you, whichever floats your boat, but that's what it factorizes to. So x equals 8 or positive 2 are the two solutions. Moving on to question 20, it says P, Q and R have positive values. P is directly proportional to Q, where P equals 8 and Q equals 2. R is inversely proportional to Q squared, when R equals 10, Q equals 3. Work out the value of R when P equals 0.5. And this is for 5 marks. So first thing what we want to do is, this is a double direct and a combination of direct and indirect proportion. So let's have a look at this first element here. So we've got P is directly proportional to Q. So we then equals KQ. We then use these values to work out the value of K. So P equals 8 and K equals 2. So therefore K is going to equal 4. So the formula for PQ, so combining these two things together, we get P equals 4Q, and that's one of the formulas. Then using this bit of information here, let's call that number 2, we get that R is inversely proportional to Q squared. So R is equal to K over Q squared. When R equals 10, Q equals 3, so I get K over 9. So K equals 90. So in the formula for combining this and this, we get our formula of R equals 90 over Q squared. So using these two formulas, we can then work out what the question is. So when P equals 0.5, we get 0.5 equals 4Q. So then that's going to equal 0.125 equals Q. And then if I then substitute that into the formula, so R equals 90 over 0.125 squared, and I type that into my calculator, and I get a value of 90 divided by 0.125 squared. I get an answer of 5760, and there is my answer for that one. Moving on to question 21, it says a cylinder C and a sphere S have the same radius R. C has a height of h. We've got the formula for the sphere, and it says the volume of C is equal to volume of S. Work out the ratio of R to H, and you must show your working out. So let's have a look at this particular question. So to start off with, let's first of all work out the formula for the volume of the cylinder. So this particular shape is going to be pi r squared times h, and for the sphere we're told it's 4/3 pi r cubed. So as I've got the same volume, we can then make these equal to each other. So pi r squared h is equal to 4/3 pi r cubed, and what we want to do is we want to write a formula using r and h. So we can cancel the pi's straight away, and I can also divide both sides by r squared, so that just leaves me with h equals 4/3 r. Now going back to the question, we want the ratio of r to h, so if I take h over to the other side and then flip the fraction, so I get 3/4 equals r over h, then what I then from this that gives me is, it tells me that the ratio of r to h is in the ratio of 3/4, and there is my final answer. Moving on to 21b, it says that a different cylinder has a radius of 3r and a height of 2h. How many times bigger is the volume of the cylinder to the volume of C? So for this particular question, what we need to do is first of all work out the volume of C, which was pi r squared h, and then the new cylinder, so new C is going to be pi times, and it's going to be the radius squared multiplied by the height, which is 2h. Then if I simplify all this, I get pi times 9r r squared times 2h, and simplify that further, and I get 18 pi r squared h. So comparing this to this, how many times bigger is it? Well, I'm going from 1 pi r squared to 18 pi r squared, so then it's going to be 18 times bigger. It then says for question 22 that Fatima is choosing a 4-digit code. Each digit is a whole number from 0 to 9. She decides all her digits will be odd numbers. No digits will be repeated. How many different codes can she make? Well, if all her digits are odd numbers, then the numbers you're going to choose are 1, 3, 5, 7 and 9. And if no digits are repeated, well, for the first digit there are 5 options. For the second number there are 4 options. For the third digit there are 3, and then for the last digit there are 2 options to choose from. So all I then need to do is 5 times 4 times 3 times 2, which gives me a final answer of 120. Then moving on to question 23, it says a quadrilateral ABCD is reflected in edge BC. How many vertices are invariant? So in other words, don't move. So how many vertices are there? Well, there's 2 that are going to be staying the same, or is reflected on BC, which is one of the sides. So therefore we're going to have 2 invariant sort of vertices. And then for the last question, it says write 2x squared minus 12x plus 7 in the form of completing the square. So a couple of ways in which we could do this. I personally prefer factorizing. So if I just write out the question first, then I want to write with a single x, so I take 2 out. So I've got x squared plus 6x plus 7 over 2. Then I can then use completing the square on this square bracket. So what that then becomes is x minus 3 squared plus, let's say, 3.5 minus 9. And again, I can't forget that 2, so let me just put that 2 there. Then if I neaten all of this together, I get 2, and then I've got x minus 3 squared, and then 3.5 minus 9 is going to give me 5.5. And that's plus 5.5, oh no, minus 5.5. And then all that's left for me to then do is multiply out the 2. So multiplying the 2, I get 2 lots of x plus 3 squared, and 5.5 times 2 is 11, and there is my final answer. Now in the description I'll put the grade boundaries for both this individual paper, but I'll also do, if you've done all 3 papers, I'll put the final grade boundaries for this June 2024 series papers.